Hello everyone, welcome back to my channel. And I was just recently started working on Carpenter. Carpenter is not the physical Carpenter, but I'm talking about the Carpenter in cluster as a cluster autoscaler in Kubernetes. And in this video, what I thought is like before I provide how to a step-by-step guide to explain and install Carpenter inside your EKS, which is Elastic Kubernetes Cluster, why don't we just go a little more basic understanding of what's the main difference between Carpenter versus the cluster autoscaler. So just gonna zoom in. Just using a simple, I think it's a Microsoft OneNote app in my iPad for the explanation purposes. I'm not good with all the editing and all software, so apologies on that part. But hopefully, this explanations using the iPad would give some more clear clarification and understanding of the auto scaling. Why do we need it? What's the key difference between the Carpenter versus cluster autoscaler? Why does the Carpenter come into the picture, and why does now AWS team, the open source community as well, managing and keep releasing a new version? By the time of recording this video, as you can see, is Saturday 21st of December 2024. So let's begin. All right. Before we go into the auto scaling side, we need to understand the basic things in a Kubernetes or in a case of EKS. So Elastic Kubernetes service is a service provided by AWS, and in this way of providing and managing your Kubernetes, there is two things. One is the control plane, and the second is the nodes. The nodes is nothing just a worker nodes. So the control plane managed by AWS, and we as a consumer of AWS, we manages the worker nodes. So this is a consumer side. Pardon my language if some things is not clear, but I'm speaking as well, so hopefully it makes sense when I'm speaking and writing as well. So to understand a little more, there is another thing which is called a data plane. So the way things work, so all your kubeproxy add-ons, core DNS, that is the ones which are responsible to making a communication between these two, the control plane versus the worker node. These are the responsible ones, including the VPC and so on. There are so many add-ons now supported by AWS. You can have a full list. I can provide the links bottom below in this YouTube video link. All right, so in the cluster autoscaler, if you ever has used cluster autoscaler, you can install through the Kubernetes simple manifest YAML, or you can install it via Helm. It doesn't matter whichever the way you use, but ideally, in my experience, what I have used is like using a EKCTL, or you can use CloudFormation, you can use Terraform, doesn't matter, whichever the infrastructure as a code tool utility you want to use, you can use it. The way I was most of the time in the past or using is by this way. So you create node groups. The node groups or the node pool, which is mostly term used in the Azure Kubernetes service or the Google Kubernetes engine. In case of AWS, most of the time they will just using the terminology called node group. Inside a node group, you have multiple nodes running, let's say call N1 up to NN. And the way until now, what I was using with the help of cluster autoscaler is like so you create, this is your EKS, and this EKS is going to have, let's say, 3 node groups, NG1, NG2, NG3, and these 3 node groups, each node group deployed in one of the availability zones. So let's say this is AZ1, AZ2, and AZ3, and let's say this all 3 availability zones belongs to a single AWS region, and let's say we don't have more than 3 regions, so we are not looking into Virginia or Ohio or some other regions which have probably 5 to 6. So let's say it's a Sydney or Singapore, Mumbai, any top sort of regions where we only have 3 availability zones. Now, what we have is we have the EKS running in 3 different availabilities. Each node group contains multiple nodes, and let's say I'm just going to pick up one node group. Now, this node group, as I mentioned, node group is nothing. It's just to consist of your N1 to NN, which is your nodes. Nodes, what is a node is nothing. I'm just in a simple terms, I'm just talking about EC2. Behind the scene, it's just spinning up a EC2. I'm not going to Fargate. We're just talking about here a managed node groups. You can see the difference between managed versus unmanaged and what's the services now they offer is EKS Auto, which is recently released, and also the Fargate service. But here we are just talking about a simple node group with multiple EC2 nodes. And let's say all three node groups, these three all running M6I large instance type. So what does mean is to make sure all the worker nodes going to be in a high availability and my ports can schedule on any availability zone, and I'm spinning up M6I large instances in availability zone 1, 2, and 3, not in the same node group. You can create a single node group, and you put all the availability zone in all three together, or you can just put it one availability zone. Either one, both works fine. But I'm just considering the case here that we have three node groups. Each node groups consists of multiple nodes, and those node groups are deployed in a specific region, availability zone, sorry, in each of them. Now, if you're using a cluster autoscaler in your Kubernetes, the challenge you will have is you cannot have in a same node group M6I large and M7I extra large, T3 medium, etc. If you're going to create a node group and you say, I want to have a node group with multiple instances type, and then you say in all three availability zone, it can be spot, it can be on demand, the cluster autoscaler will not going to work. The cluster autoscaler, what it's going to do is it's going to pick up whichever is provided first at the time. So how do we solve this problem? You can solve the problem of cluster autoscaler or CA. I'm just going to use the term CA here. You can create node groups. Let's say node group 1, node group 2, and node group 3. You can use a different instance family generations, but you can't change the type or the size. What does it mean is I can have a T3 large, T3 large, or T2 large, all of them, or T2 large, because all will be providing me, I think, 2 virtual CPU and 4 GB of RAM. So if I put it in the same here, another one which is called, let's say, T4G extra large, the cluster autoscaler will only going to choose between these three, not this one, because now I'm actually moved to 4 CPU with 8 GB of RAM as an example. I might be wrong with the GPU and CPU, so make sure you just double check it. I'm just giving us a reference example. Similarly, in case of node group 2, I can go for M6I large, M7I large, I can go for M5 dot large if it exists, but I can't have M6I large and M7I extra large in the same node group. You can have it, nothing going to stop you when you're trying to provision a node group, but the cluster autoscaler will never gonna use this, it will use this. But if you put M7I first, extra large, and then you put M6I large, then M7I all the time gonna spin up. Now, it maybe depends upon how much is the min, max, and desired you put. So each node group going to have a minimum, how many nodes we need. So minimum nodes. Then we need let me just clear this. Minimum node, maximum node, and desired node. So minimum node, let's say each node group, I'd say minimum all the time, at least 1. Maximum, let's say 20. And desired, I'm saying 2. Which means is, I'm saying the minimum 1 EC2 instance of M76I large needs to be running 24/7. It can be spot, it can be on demand, it can be reserved, doesn't matter. Maximum, you can have 20 EC2 of the same category, or M7I, or M5. I'm just picking up here this one as an example. Okay, and the 2 is initially when you're creating that node group, you're saying that I want to have spin up 2 EC2 at this time of creation, or it's currently at the desired status 2, and the cluster autoscaler will be handling scaling up and down. It cannot go less than 0, less than 1, which is going to be 0, and it cannot go more than 20 because that's what we have put it in the node group. And similarly, it can go between 1 to 20 min and max value. It's like a math. Simple. I hope so far we get some clear understanding how does the Kubernetes cluster works, the control plane, data plane, and the worker nodes. You can install through the Kubernetes Helm and everything. This is the first time I'm doing it, so apologies if I'm not good in explanation either. Okay, now other thing. So cluster autoscaler, as I mentioned, the main disadvantage for us is simple, is that our cluster autoscaler can only able to handle in our node groups, the CA, we have to define the same time. And now I'll tell you the disadvantage of the cluster autoscaler. It's good, it's fast, it's stable. The main disadvantage based on my experience after working in the industry for so long is, so let's say you have an applications running. Let's say you have one application, AP1, AP2, AP3. And let's consider we have 2 nodes in our cluster only. And I'm just going to pick up the example of M6R large. M6R large will give us 2 virtual CPU and 8 GB of RAM. Okay. And let's say these 2 nodes running is a part of a node group. And that node group has 1, 5, and currently 2. So 2 is our desired capacity, which is currently running. Maximum it can goes to 5, and minimum 1 needs to be running all the time. Now let's say the application 1 requires a 1 CPU request and 4 RAM. AP2 requires let's say 1 CPU and 4 RAM, and AP3 required 1.2 CPU and again 4 GB of RAM. So 3 applications, 1.2 CPU, 4. Now let's say this is my node. Okay, so the node, of course the OS will be taking some part of it. So what we're left with, I need to put, so the kube scheduler will be deciding, and let's say we have 2 nodes, right? That's what we provided. So out of 8, I'm not going to get 8, and same for CPU, I'm not going to get 2. I will be getting around like a 1.8 core CPU, and I'm not going to get 8, I will be getting around like 7.6 GB RAM. So 400 memory will be used by the OS as well. So we have to keep in mind there is operating system running on each your EC2 compute instances. So what does it mean is, if I need to put these 2, and let's say the kube scheduler in Kubernetes deciding, okay, I'll put the first application because, and let's say these are currently no other applications, nothing else running, no add-ons much apart from minimal ones as a daemon set or as a deployment, doesn't matter what they're running. So they're just consuming 100 millicore of CPU or memory, doesn't matter. So let's say we left with 1.6 each. So we left here, let's say 1.6 virtual CPU and 7.6 GB of RAM. And same applies here, okay? So I can just put my first application by the scheduler on here. So AP1 comes here. So which means is I left with only now 0.6 virtual CPU. Right, okay. Now, and this is, by the way, I'm putting here, this is the request, not the limits. Okay, so this is the request. So minimum, my 3 applications need 1, and 1.2. So what does it mean? 1 core of CPU is gone. So I left with only 0.6. Can I fill AP2 or AP3? No, I can't. So that means the kube scheduler has to utilize another node, which is AP second node. And this is called node 1. And this is called node 2. So AP1 goes here. AP2, let's say, goes here, because initially we only have 2 desired state here. So that means I can't have more than 2 at this stage. So AP2 is filled up here, which means is again I left with 0.6 virtual CPU. What about AP3? AP3 will not going to go anywhere. AP3, if in order for AP3 to come and the deployment or the applications need to come alive, the cluster autoscaler has to spin up a new OS. As I mentioned, we are using M6I large, which means is again it's going to be 2 virtual CPU with 8, because we have a maximum 5, right? So the node 3 will going to spin up by the cluster autoscaler if it's configured correctly, and AP3 will go here. Now Again, I left with zero point 0.6 virtual CPU. We can clearly see the problem itself while I'm explaining it here. And of course, like first, the yeah, because we have 7.6, 4 easily can fit in, 4 the same here, and 4 here. So RAM is not a problem, CPU is the biggest problem here. And we can clearly see that I wasted almost 0.6 into 3, because 3 nodes, 1.8 virtual CPU. So it's currently wasting by me. And this is one of the example where cluster autoscaler, it's scaling up horizontally, like for me, adding a new nodes to, because I have a maximum, I can have the node group with 5. But the clear problem for us is it's wasting a lot of CPU. This application is running here, but this space is empty, which means is whether I use or not, AWS will be keep charging you for 24/7. Yes, you can save money, but go for the reserved or go for the on spot instances, but you're still wasting not utilizing it at max capacity. And that's where the Karpenter comes into the picture. The benefit of a Karpenter is you create two things. One is the node class, and second is the node pool. In Karpenter, in the node class, what you have is you just provide a different, all the definitions I will be explaining in the code base when we will go in the next video. But in this one, I will just gonna explain it. In the node class, you will provide the AMI or the AMI selector, type of AMI to use for your AMD, ARM, GPU base, etc. And which AMI to use based on your Kubernetes version. So let's say if you're on 130, you'd specify a specific AMI to be used by it. But if you're on 1.31, you need to specify different AMIs. In the Karpenter documentation, I'll show you guys how you can just running the AWS SSM parameter command, where they store it on the parameter store to fetch that value without using any AWS authentication. Okay. So in the node class, as I mentioned, the Karpenter belongs have two main things, which is the node class and the node pool. The node class, where you provide the type of classes for AMI, ARM, your CPU, GPU, depends upon what you want to use based on your version of Kubernetes. That's pretty much it, nothing much. The node pool is the main ones where we play around and do all the funky stuff. Here we put about the budget, how long we want to run the nodes, and you can specify the instance type. You can put the limit of your memory or CPU, that how many it can spin up. And also here you can specify the instance category. Now, if we consider the same example which I just explained here, the problem for us is we are wasting a lot of our EC2 nodes, although it can be just reduced down, because I can't spin up here like first node is M6I large, and the 7 one is M7 medium if it exists, or T3 medium, to a smaller size. But you can't do that unless you're specifying all these, each individual node in a separate node groups with the same sizes. Then the only way the cluster autoscaler can scale up. And this is the problems with the Karpenter we try to solve. So in the case of, as I mentioned, in the node pool, just to repeat again on the node class, you're doing nothing. You're just providing the AMI and the type of AMI selector. You can also use this, the alias or the regex pattern, to pull the latest images, which is not recommended in a production environment, because it can have a breaking changes and it can cause an impact on your whole production. So I don't recommend either. But you can go for specific AMIs to use for your AMD or ARM based on the versions using the AWS SSM parameter in the node class. In the node pool, what do we do? Focus on the budget disruptions of the nodes, how long we want to leave the nodes, instance types of the node, whether it's going to be compute specific or memory specific or journal purpose, the type of categories, and we want to specify the limit and memory in the node pools. And there is so many other things you can do and play around it. And in the case of above example, which I just discussed, in case of, if you have a right node pool, let me just zoom in here, much better. So in the node pool, what you do is, like, let's say we provided just use for M series and T series. Okay, so this is a CPU burstable series, and this is just a normal M series, which is both comes in a general purpose, but M series are mostly contains a higher spec as compared to T, which is belongs to T2, T3, T3A, and now T4G, which is the graviton base. M series is M4, M5, M6, M7, and M7G and M7I might be not available in all the regions, so just double check. Most of it's now available, but it might be still not available in all the regions, including China. All right. So now the main thing is in the node pool. So let's say we have two specified series. Now, if we need to solve the same problem with AP1, application 2, and application 3, again, 1 CPU and 4 GB RAM. Same here, and 1 point virtual CPU and 4 GB RAM. The way Karpenter will be solving this problem, and let's say we have running two desired EC2 of M6I large initially, and then you install Karpenter. Then Karpenter, what we're going to do is it's going to using a node pool where we're providing what series to use. So it's going to look for what's the best way, because total I have 1 plus 1 plus 1.2 virtual CPU. So in total I need is 3.1 virtual CPU, and total memory I needed is 4 into 3, which is 12 GB RAM. So the one of the best simplest option for me, kill these two nodes because I don't want to nuke anymore, and just spin up a 1 EC2 which has 4 virtual CPU and 16 GB of RAM. Wonderful. Which instance can be simply M6I extra large. So I don't even need to run two instances. I can just run one instance, M6I extra large, and I can fulfill all three of them in a single node. And yes, you will still going to waste a little amount because you have 16 total RAM. So let's say OS is occupying 400 memory again. So you're left with 15.8 GB memory, which is RAM. And the CPU is 4, so and you get, let's say, 3.8. Okay. So you're still able to fill because 3.2 and 12 easy. Why? Because in the node pool, we just said, let's say, just use any M series and any T series. We didn't specify or restricted to use M7, let's say, large and M6I large. You can do that. You can restrict it and you say T3 or T4G large. You can restrict it as well in the node pool. The only use a specific type of instance. But if you don't specify, the Karpenter will try to find what's the best way to accommodate three applications in an isolated environment to fulfill the need. And we can clearly see this is a much better option for us as compared to this way where we were wasting a lot more resources. Right? So yeah, that's pretty great. Okay. Now, can I use spot? Can I use on demand? Yes, you can. Again, define it in the node pool, and we will see those information as well. Now, here's another thing which I recently was playing around with Karpenter and I come across. It can be very damaging as well. So what I did is, like, I had a simple use case as above, but then I spin up an Nginx pod running a kubectl. And what I did is I actually say, because I want to see the performance of Karpenter in my Kubernetes cluster, so I said, spin up a 2000 replicas of it. You know what the Karpenter does? Yeah, it's trying to perform the job to make all the pending pods into running as soon as possible. So it spin up M7I 24 extra large. This one is contains, I think, 48 virtual CPU or 50 virtual CPU with 192 GB of RAM. I like the idea that it's able to accommodate 2000 replicas in a less than 2-3 minutes, but this is very expensive, very, very expensive. And if you don't have a good amount of alerting, what does it mean is, without realizing, because you're not putting any control apart from telling Karpenter to use which series or what type of instances, it will going to spin up any matter of high instance if it's available in that region to fulfill the requirements and need. And this is one of the drawback from my point of view. Not a drawback, but it's very things to be careful about the costing. Although Karpenter we are trying to use and leverage to optimize our cost, but also make our cost down. But in this suppose unique case, my cost went up and I straightforward realized, holy cow, like I don't need 24 extra large because I was mostly using M6I large in my workload and I'm going for a reserved 3 years plan. So for me, the better choice was just use this. So what you can do to make sure Karpenter is able to spin up but not go over a certain limit, that's where you put a limit on the node pool. So if you put a node pool with a limit of, let's say, don't go over 20 virtual CPUs, doesn't matter whatever the MOT3 is trying to spin, the total aggregation cost will never gonna go over 20 CPUs. So one way is you can control this. Second way, you can also say, I want to use T4G medium T4G large, and here we can find like a 1 CPU, 2 RAM, 2 virtual CPU, 4 GB RAM in a same node pool. Doesn't matter. You can create multiple node pools, but we will just going to use some one. Similarly, XI large, M7I large, and let's say I'm going for another one which is M5I large, and I said M6I extra large. The reason I'm just sticking with T specific 1, 2, 3, 4, 5, 6 instances, because let's say you're went for a savings plans on your organizations to save the cost as well, and this will give you much more benefit. And then there is no way, if it's need to fill 2000 replicas of Nginx port as an example, it will try to spin up multiple of M6I extra large to meet the requirement as soon as possible, which is on the savings plan, rather than spinning up something extra large like M7I 24 extra large, which is costing me a lot more fortune money. So that's the main informations on the all the Kubernetes sites, and I hope you get some more clarification and idea about how does the whole EKS Karpenter works, and what's the main key performance issues as a user you will face in Cluster Autoscaler. It's not bad, to be honest. Cluster Autoscaler you can still use. In my opinion, it still functionally works better, but you can leverage with Karpenter if you tune it in the right way. If you don't know how you're tuning, or you don't know about your workloads and it's not consistent, and you want to have a dynamically change the instance type of it in the spot or on demand, you go for the Karpenter, but making sure you limit with some CPU or memory. Otherwise it can spin up a very, very high intensive easy to compute instances based on to meet the requirement, to meet your demand of the traffic or the application you're trying to spin up. So just to think about it, I hope you find this video much informative, and I will see you in the next video for explaining, and we will go in depth, and we will be installing the Karpenter in the next video. Thank you. Bye bye.